to write and graph linear equations. Today we're going to primarily look at rewriting linear equations and then graph those linear equations. So now, and let's look at the problems here. In the vocabulary on your page, you have one more vocabulary there. It says intercepts. You do not need to write this. It's already on your page, and we'll define that momentarily. So the first thing I want to point out is that linear equations can be written in standard form, and this is the basic form of standard form. And it looks like this. We do use capital letters for these coefficients and constants for whatever reason. Something else to point out is that the A, the B, and the C are all integers. That means they're the whole numbers and the negatives. So positive 6, negative 3, etc. Generally speaking, standard form has the variables on one side. X is here, Y is here. Over on this side is a constant. Sign in, please. And over here, I do want to point out that generally speaking, A is positive. It doesn't have to be, but generally speaking, A is positive. Let's look at the most common way that we talk about linear equations, and it looks like this. Y equals mx plus b. And that's called slope-intercept form. In my notes, I tend to abbreviate that with an m-int. That's how I abbreviate slope-intercept form, just when I'm going fast. That is not true for all mathematicians. All right. Now, of course, we know what m means. M simply means your slope. And b is your y-intercept. M is a nice thing because it tells me how to move. How to get from one point to the next. How to move. So I like to remember that as M for move. And B for where to begin. Say, for example, let's meet at the mall, buy the Krispy Kreme, and then we'll move on over to the theater. Okay? So we have instructions on where to meet and then where we go from there. Example number 1, we are asked to find the slope and y-intercept of the line. Then we're going to spend some time graphing it. So, notice what slope-intercept form looks like. What letter is all by its little lonesome self? It's the y. So I need to get everything else to the other side and y all by himself. So I'm going to staple y to the page and get rid of everything else around it. So how do I do that? First, I'm going to shift the y over, the x, by taking the inverse. I'm going to bring down, don't forget to bring down the negative 2, not just a 2, but a negative 2y. And although we can read this as negative 6 minus 3x, because slope-intercept form has the x first, I'm just going to write that first. So negative 3x, bring down the minus 6. Now in order to get the y by itself, I have to divide by a negative 2. So I'm going to go all across the board there. Next, I'm going to have y equals 3 halves, because the double negative is positive, minus 3. Please take a moment to see where my mistake is and talk to your neighbor. Good, so I did make a mistake. That should have been negative, and now it's been rectified. Now, so my actual answer, it says find the slope and the y-intercept. So here's my answer that I'll box or circle. My slope is 3 halves, and my y-intercept is positive 3. So this is the part that I box or circle, because that's what the instructions ask me to do. Now from here, it does ask me to graph. And this now is my code. This tells me where to begin. I'm going to begin at positive 3 on the y-axis. And this tells me how to move. Just to recollect how I move, this means I go up 3 because it's a positive 3, and then right 2. However, You could translate that to be down 3 and left 2. Why did I do that? Well, down is negative and left is negative. So a double negative is still positive. So 3 over 2 can be interpreted as positives or as both negative. Both are valid. So if I just sketch this out real quick, I'm going to start here and I'm going to go up this direction. Notice what I don't need. I probably don't need those lower quadrants. So that's just a quick sketch. You don't have to do that. But when I do actually make my graph here, I want to make it look clean and only focus on the data that I need. So notice that I'm going to stay primarily in quadrant number 1. Quadrant number 1 is the top right. And just to refresh your memory, quadrant number 2 is over here. Quadrant number 3 is the negative quadrant. And quadrant number 4 is there. So remember, the B tells me to begin at 3, so I will. Here is my 0. Here's 1, 2, and so here's my beginning 3. So right there. Then the instructions tell me to go up 3, 0, 1, 2, 3, then right 2, 1, 2. So that means I can place the next point there. In other words, I go up 3, right 2. Now remember, I could have done it the other way around. I could have gone down 3 and left 2. If I do that, notice what's true about my 3 points. They're collinear. They're in a straight line. And that's exactly my expectation. You are not responsible for all 3 points. Just these 2 are sufficient. Or just these 2 are sufficient, because 2 points will make 1 line. I do want to point out, we did not, so on your vocabulary there, it says intercepts. Well, this here is my Y-intercept. It's where my graph crosses the Y-axis. And so down here is my X-intercept. That is where the graph crosses the X-intercept. I do want to clarify about whenever I say the word graph, what do I mean by that? Some of us say, oh, graph, it means the whole thing. It means everything that you did here is your graph. And the answer is no, actually. Think of this line as your book, and think of everything behind it as the bookshelf. Think of this as your car, and think of all of this over here as my garage. Because when I'm talking about the graph, I'm only talking about the blue line here, or whatever shape it is. It could be a curve too. But back here, this is just how we organize things. This coordinate plane is just the organization. It's like the garage. And this is like my car. My bookshelf here, and this is my book, or my books. So remember that the graph just means that which is associated with my original problem.